All right, for our third lesson on matrices, we're going to start looking at some ways of solving equations. And one of those methods is by using determinants. And so lesson 3 is just going to be about using determinants or finding determinants. And then we get into our next lesson, we'll see how we can use those to solve systems of equations with determinants. So a couple things. One is a determinant is just a number. And so when we do find determinants out of these, we are just getting a single number from it. It can only be used with a square matrix. In other words, the dimensions have to be the same. It has to be a 2 by 2 or a 3 by 3 or a 4 by 4 in order to do this with. We're only going to do them for 2s and 3s. And then the notation that you need to know is it kind of looks like absolute value brackets. So if I give you the name of a matrix and we call it matrix A, so the determinant of matrix A would look like this. So these are the symbols that you have to be familiar with. Looks like absolute value brackets. When you're doing it for a 2 by 2 matrix, it's very simple. In either case, whether it's a 2 by 2 or a 3 by 3, the rule is you're going to do your downward diagonals minus your upward diagonals. So that's always kind of a good thing to throw into your notes, but we're going to say downward minus upward. So if you look at the 2 by 2 matrix that you see right here, we're going to do our downward diagonal, which is A times D, minus the upward diagonal, which is C times B. And so that's kind of what you're seeing right here is we're doing AD minus CB is the way we would lay that out. And so if we throw some real numbers into that and simplify it, we would just get our determinant, which again is just a single number. So let me show you one with some real numbers plugged into that. So here's a 2 by 2 matrix. And again, I'm going to do my downward diagonals minus my upward diagonal. So I'm going to do 4 times 2 minus 5 times negative 3 to get it. So here's the work laid out for you. So this is our downward diagonal minus the upward diagonal. So if we do a little cleanup on that, you can see we get our determinant, which for that one would be 23. Real simple with a 2 by 2 because there's only a couple numbers to look at. You can see with a 3 by 3 a little more going on there, and so that's what we'll talk about next. So with your 3 by 3s, it's still the same rule. I'm still doing my, let me take you up to one that hasn't been written on yet. I'm still doing my downward diagonals minus the upward diagonals. The issue on this is you have more than one diagonal. If you look at the main diagonal that runs right through the middle, this is where things would start. So I would be doing that times that times that as my first diagonal. And so that's what you're seeing laid out as our first step in the process right here. The issue is when you get to the next diagonal, you'll notice there's a number missing. So where does that number come from? So if you look at that times that times that, we need a number here. So what happens is you take the first value and it wraps around, and so I would be doing B times F times G to get my next diagonal, and then same thing here. I have another one where I have to involve this guy, and so he's now missing this number, which if I wrap it around would be D, as well as the next number, which I wrap around and make it H. So anyway, all that's really tough to do visually. So the easier approach to this, instead of trying to have to wrap around to a previous number, it's much more easy if we just rewrite the first 2 columns. So you'll notice in the setup down here, here's the original 3 by 3 matrix. So all we did to make this easier on ourselves is we rewrote the first column right here, and then I'm going to rewrite the second column right here. And so now as I go in to draw those diagonals, so you can see I have A times E times I, and now I have B times F times G, and it's already there for me. I didn't have to try to visually wrap around and see what the next number in the list was. So it's just already laid out for me. Same thing with my third diagonal here. If I did C times D times H, right, I got that next number. And so a lot easier instead of having to try to visually pull the D around and then pull the H around, it's easier if we just rewrite those columns to do it. So the way you'll always start a 3x3 determinant is to first rewrite the first two columns so that it looks like this. And then again, you're going to do your downwards minus your upwards. So these are my downward diagonals minus my upward diagonals. So you can see I have that times that times that plus B times F times G plus C times D times H. And so those three make up my downward diagonals, and we're adding those together. Then I'm going to do my upward diagonals. So G times E times C, it always starts in the main diagonal. So I multiply those three together, then I multiply those three together, then I multiply those three together, and that's what you're seeing in my second set of parentheses right here. So those are the upward diagonals that you're seeing on those. Oftentimes, I see people who are especially like a big fan of like using a highlighter or something like that. They will either draw lines like I did, or they use like a highlighter, and so that maybe they'll do their downward diagonals in yellow just to make sure the numbers are lined up, and then they'll do like the upward diagonals in pink or something like that, and just to help kind of distinguish the numbers and make sure you're lining everything up properly. So let me show you one case where this is going on here. So let me show you the original matrix on this first, before it had any writing on it, so you can kind of see the process that we took on this. So here's what that looked like before it had any writing on it. And so again, if I had a 3x3, I'm going to start by rewriting the first column, 1, -1, and 0. Make sure you keep everything nice and lined up. And then 1, 3, 2. So it would look like this. And so that's got to be my first step. And then I'm going to do my downward diagonals, which is 1 times 3 times 6 plus 1 times 4 times 0 plus 2 times -1 times 2. And those would make up my downwards. Then I'm going to do my upwards, which would start right here in the main diagonal. Multiply those plus those plus those. Right? And then I'm going to do my downwards minus my upwards. So here's what it looks like when it was all played out. And so here's what I was referring to earlier. Some people like to use some color in there to maybe help distinguish what things are. And so you can see the yellow ones were the downwards, and that's where we're getting this group of numbers right here. The pink ones were my upwards, which were those. And then at the end of all that, we're going to find the difference. We're doing our downward minus the upward to get our determinant. So that's the determinant for a 3x3. I think really the hardest part about that process is just making sure you don't make little mistakes along the way. I'll have people do 1 times 4 times 0 and get 4. All right, or something like that, and forget, oh yeah, 0 times everything is 0. So little things like that you just got to be careful of. Otherwise, the process really isn't that bad. So here's one of the uses of a determinant, and that is for finding the area of a triangle. And so if this is your 3x3 matrix, so you can see here's our triangle right here. So this is x1 and y1. That just means that's our first coordinate points. All right, that's one of our vertices. This is x2 and y2. That is our second set of vertices, or set of points for that vertex. And then you have x3 and y3, which is our third vertex. And so if we put those numbers into a 3x3 matrix, then we have our first x and y. That's one of the vertices. And the order of this doesn't really matter as long as you keep your points together. So this is one vertex on the triangle, that's another vertex on the triangle, and that's another vertex on the triangle. Remember, to do a determinant, you have to have a square matrix. So if I left it as a 3x2, I couldn't do a determinant on this. So we need to make it a square matrix. So we just fill in the third column with 1s. So now it's a 3x3 square matrix. And now I can do a determinant. Putting the 1s in there, remember, as you multiply anything times 1, obviously does not change the value of what you have. And so that's why we can fill it in with 1s just to complete the process here. When you find the determinant on this, so remember, these brackets are here to tell you we are finding a determinant. That's one of our symbols. So we're finding the determinant of this matrix, and then we multiply it by a half. Just like doing 1/2 base times height. is kind of really where this comes from. So that's kind of all that's going on with this. Cool thing about this though is it works for any triangle. It doesn't have to be a right triangle. When you do base times height with that formula, it has to come from a right triangle, or you have to be able to identify the base and the height. This works for every triangle. It doesn't have to be a right triangle or for you to even clearly see the base and the height on it, which is kind of cool. Anyway, the little plus or minus is in the front simply to tell you that we always need a positive value. We're finding the area of a triangle, and an area could never be negative. So this just helps clean up whatever needs done at the end. So if you happen to get a negative determinant, then we would multiply it by negative 1/2 in order to turn it into a positive. If it was already positive, we multiply it by positive 1/2 so that it stays positive. And so that's all that's going on with that one. Let me show you one with real numbers. I'll give you the color-coded version here. So we had a triangle with these coordinates, so -3, 2, 3, 3, and 1, -1. And again, the order on this doesn't really matter as long as you keep your numbers paired up. So I took that vertex, so here's -3, 2. So I'm putting all of my x's in this column, I'm putting all of my y's in this column, and then remember we fill in the third column with 1, 1, 1 so that we have a square matrix. So -3, 2 was a vertex, 3, 3 was a vertex, and then right down here 1, -1 was our third vertex. And so there's my three ordered pairs. I got my 1's in column 3, and now we're right back to doing what we did when I showed you how to do a determinant of a 3x3 matrix. So we're going to be doing our downward diagonals minus the upward diagonals. So you see the 3 yellow downward diagonals. Again, remember at the start of this, I repeated column 1 and column 2 in order to get my all my numbers set up so that I could do my downwards minus my upwards. And so you got the yellow ones minus the pink ones, just like we did on the last page. You can see that gave us a determinant of -22. So I'm going to multiply that by -1/2 in order to create the positive area for that. So don't forget to always multiply that determinant by 1/2 to get your area. And again, we're going to pick the sign that allows our area to come out to be a positive number. And that's it.